Hi, I'm Cameron Tenner from FlowWest, and I'm going to walk you through the modeling results from the second round of modeling on Fish Hatchery Creek in the Giacomini wetlands. So first, to kind of orient us and to see where this model is, here's a kind of overview with satellite imagery of the Giacomini wetlands right here. Lagunitas Creek coming into the Giacomini wetlands. Smalley's Bay is just north of this, and right here is Point Reyes Station. So we're looking at Fish Hatchery Creek, which I'm going to zoom in on right down here. And you can see that Fish Hatchery Creek on the satellite imagery is right here following this kind of line of trees. And it kind of, the part we're looking at starts right off of Sir Francis Drake at a culvert and kind of feeds into the western pasture of the Giacomini wetlands. Some things of note are that there is a private property denoted by this red polygon right here, directly next to the current alignment of Fish Hatchery Creek. And as you'll see, the current alignment actually goes partially through this private property. So I'm going to turn off our satellite imagery, and this is the digital elevation model of the Giacomini wetlands. And you will see Fish Hatchery Creek is right here. This is the current alignment. It starts at this culvert that comes out from under Sir Francis Drake Boulevard, and it goes through private property and then into this area that is, continually dredged by the National Park Service, and it stops kind of right here and empties into the western pasture. So we modeled 7 alternatives representing 7 kind of approaches to the continued management of Fish Hatchery Creek. And I'm going to walk you through those. We have 8 alternatives, modeled 8 alternatives of representing different approaches to the management of Fish Hatchery Creek into the future. So I'm going to walk through those 7 alternatives. So I'm going to walk through those 8 alternatives, and after that, I will then go through the modeling results for those 8 alternatives. So our first alternative is a no action alternative. This represents a condition where we let no management is done on behalf of the county or the National Park Service, and we allow the current Fish Hatchery Creek channel to fill sediment. And we're predicting that over time, this will come to be represented by the 2009 LiDAR that the National Park Service took for the Giacomini Wetlands Restoration Project. So we're using this 2009 LiDAR to represent this no action alternative, and the water will basically come in right here at the culvert and be allowed to spread across the western pasture according to this terrain. Now, the second alternative is a slight modification on this no action alternative. However, we put in a berm along the south of the current Fish Hatchery Creek alignment that is owned by the National Park Service. So you'll notice that the current alignment is right here. We're putting a berm in along the south of the current alignment, only on the land that is owned by the National Park Service. The third alternative is to create a short northward alignment starting at the beginning of the section that is currently dredged by the National Park Service, extending it about 250 feet north with a berm to the east. And again, note here that there's no excavation or management of the channel on private property. Now, alternative 4 is basically the continued management of alternative 4 is having the current channel that's on private property to be continually managed, so there is a channel from the culvert to the area that currently starts the National Park Service dredging. Now, alternative 5 is kind of a combination of alternatives 3 and 4, where we have this northward alignment with this berm, but we also have this channel on the private property connecting the culvert outlet to that channel, and you can see it right here. So it's basically this whole extent right here. And the 6th alignment is to excavate a new eastward alignment connecting to the old slough, and with a berm to the south to make sure the water gets to the old slough. So that is right here. The idea is to start a channel at the beginning of the section that is currently managed and dredged by the National Park Service, extending it around the private property with a berm to prevent flooding into the private property, and connect it down here to the old slough, which then conveys water up into the western pasture and eventually to Smallings Bay. The 7th alternative is to add the private property channel to alternative 6 to make sure the water gets to this new alignment. And our 8th alignment is basically having combining alternative 3 with, I'm going to restart that. Alternative 8 is to extend the berm on alternative 3 to connect with Sir Francis Drake. So there's no excavated channel on private property, but there is a berm extending down on the private property into Sir Francis Drake. So those are all 8 of the alternatives that we are modeling. And I will now go into the results of the modeling on these alternatives. So for every single one of these alternatives, excuse me, sorry, my nose is a bit stuffed up. For each of these 8 alternatives, we modeled a 2-year storm event, a 5-year storm event, and a 10-year storm event using the mean tide level as the downstream boundary. So I'm going to walk us through the results for each of these flows. So for alternative 1, I'm only going to show the results from the 10-year flow because the 2 and the 5 have the exact same patterns, just a little bit less intense in terms of the volume of flow. So here is, I'm going to slide us through kind of the development of the flow for the first alternative at 10 years. So first we get the flow going northward, and we have flow starting to go eastward through the private property, and eventually we get a bit of flow following the kind of current alignment path. But in the end, you can see that the water kind of street flows everywhere. A lot of water is going directly north into the western pasture. A lot of water is going directly east into the private property. So when we have just this no action alternative, the water kind of sheet flows everywhere and potentially causes flooding to Sir Francis Drake to the west, and definitely causes flooding in the private property to the east. So now we're going to look at alternative 2. And again, I'm only going to show the 10-year flow for this because showing the 2 and the 5-year flow are just a bit redundant because it's showing the same thing. I'm going to walk us through this flow. Again, we have, let me turn on the correct terrain. Again, we have the initial flow going north, then we have flow start to go east, And the berm doesn't really do anything until the very end of the 10-year flow, and it does very little. It prevents a little bit of water from going through this berm, but it's not really serving a purpose because that water already got out and flooded the private property. So now we're going to move on to alternative 3. For alternative 3, I'm going to show you the 2 and the 10-year flows, and also show you kind of volumes of flow and where the kind of predominant flow paths are. So let's open the alternative 3 2-year flow. You can see that, again, like alternative 1 and 2, we have a lot of flow going north, a lot of flow going east, and in the 2-year flow towards the end, we get the northward channel activated. And if we look at the 10-year flow for alternative 3, we'll see that the channel gets activated a little earlier in the flow or in the storm and conveys some flow, but at this point we already have a lot of flow going east in the private property and just directly north into the western pasture. Now, we can show kind of graph allows us to kind of calculate volumes of flow, and by the end of the simulation, how much has gone on each flow path, whether that is directly north, directly east in the private property, or in the actual channel. And I'll just, as an example, show you what this looks like. We do a time series of volume accumulation, and this just shows us at each time step in the simulation how much volume has crossed a certain profile line. And I have gone ahead and done these calculations already. So for alternative 3, we have at the 2-year effectively no flow going up this channel. You saw some activation, but in the grand scheme of the volume, it's about 0% of the volume being carried by the channel. About 32% is going, 92% is going directly north, and about 7.5% is going directly east into the private property. In the 10-year flow, it changes a bit. We have about 0.5% being carried through this channel, about 78% going directly north, and about 21% going directly east. We will make these tables available to you to look at. But yeah, this kind of gives us an idea where the predominant flows are going. In alternative 3, most of it is not going in the channel. So this kind of channel is not being very effective or really doing much. So next, we're going to look at modification or alternative 4. And for alternative 4, we're going to look at the 2 and the 10-year flows. So first, we're going to look at the 2-year flow. And you will see that immediately this looks very different than the alternatives 1, 2, and 3, in that we don't have flow immediately going north or immediately going east. It's being carried by this channel on the private property. And then it ends and kind of just sheet flows out. Some of that's going directly north, some going kind of southeast into the private property, and some going directly east. The channel does a pretty good job of conveying flows to the end of the private property channel in the 2-year storm. Towards the end, it starts to let out kind of overflow and let some water just go directly north. We can see this pattern continued in the 10-year storm. Water going through the channel and then sheet flowing at the end of it. We start to have some overflow, but in the end, you just have some overflow going directly north, and then the flows going north, east, and southeast once it reaches the end of the channel. I've also done some, percent volume calculations here, And for the 2-year, we have initially 99% of the flow going through the channel and about 1% overflowing to the north. In the 10-year flow, that's about 5% going directly north and 95% going through the channel. Of the water that makes it through the channel, about 21% in the 2-year and 29% in the 10-year are flowing into the private property. So we still have a lot of flow going into the private property in this alternative. So now we're going to look at alternative 5. You'll see that it is the northward alignment we talked about earlier on alternative 3, with alternative 4, which is the private property channel. So we're going to look at the 2-year, the 5-year, and the 10-year flows for this one. And on the 2-year flow, you'll see that we get all the flow to the northward alignment with the private property channel, and then the northward alignment does a great job of just dumping this water into the western pasture up here, where it then slowly makes its way to the sloughs up here. If we look at the 5-year storm, we'll see that this behavior is continued, but towards the end of the 5-year flow, we start to get some overflow before the northward alignment, and this is continued in the 10-year. We get a bit more flow overflowing and going directly north, but when you look at it percentage-wise, about 99% of the 10-year flow is going through the private property channel into the north alignment and emptying into the western pasture up here, and about 1% is overflowing early. Something to note is that these kind of early overflows can be prevented with creating small berms along this channel right here. So we see that this alternative 5 works pretty well at getting the water through this area of concern, away from the road, away from the private property, and into the western pasture. Next, we're going to look at alternative 6, which is just this eastward alignment. And for alternative 6, we're going to look at the 2 and the 10-year events. So you'll notice that this is the same behavior as alternatives 1, 2, and 3, in that it is just sheet flowing a lot north and east into the private property before this excavated channel even gets activated. It eventually does towards the end of the 2-year flow, but very little water is flowing through here. It's effectively 0% when you look at all the volumes. Now let's look at this in the 10-year event. Same thing happens. Flow goes north, flow goes east. The channel eventually is activated, and when you break it down by percentage, about 0.5% flows through the channel, 78% goes directly north, and about 21% goes directly east. So, the lack of this private property channel kind of prevents this channel from being, properly utilized. So now we're going to look at alternative 7, which is alternative 6, that eastward alignment with the private property channel maintained. For alternative 7, we're going to look at the 2, the 5, and the 10-year flows. First, the 2-year flow. You'll see that the channel is pretty much immediately activated and it's carrying water into the old slough, which then is, conveying it northward to the rest of the western pasture and eventually Smalley's Bay. And you'll notice that it does a great job of conveying flows in 2-year. There's no signs of overflows over the berm or over the banks of the private property channel. So now we're going to look at the 5-year event, and it does the same thing, activates very early. However, we start to get some overflow at the very end of the 5-year event. This is pretty much 0% of the flow effectively at the 5-year, but we do start to get this overflow. And in the 10-year event, we get some more overflow towards the end, but when we break, we get some more overflow in the 10-year, but when we break it down by the percentage, about 1% of the flow is overtopping and flowing directly north into this area of the western pasture, and the rest of the flow is going down here to the old slough. So now to look at modification and, now to look at alternative 8, which is this northward alignment with the berm extended down into the private property into Sir Francis Drake Boulevard. So for alternative 8, we're going to look at the 2 and the 10-year. As the 5 is a bit redundant. At the 2-year, the water basically just starts flowing out, and it flows, sheet flows northward very similarly to, alternatives 1, 2, and 3, and 6. However, you'll notice that there isn't this eastward flow flooding the private property over here. So it basically just sheet flows north. And however, it does not really activate this northward alignment channel until the very end of the 2-year flow. So this alternative is pretty much just pushing the flow to flow naturally northwards and not really utilizing this excavated channel right here. And if we look at the 10-year, we see that the same thing happens. Eventually, the channel gets activated, but it's not conveying that much flow. When we break it down by percentages, about 99% of the flow is just sheet flowing, and about 1% is actually going through the channel. But they have the same destination, which is the western pasture directly north, where they flow into the sloughs and into the river. And one thing you will notice is that we have this kind of straight line right here cutting off the depth raster, and this is the edge of our modeling domain. So this indicates that there would be flooding on Sir Francis Drake Boulevard if this alignment were constructed. You would definitely have some kind of backwater flowing into Sir Francis Drake, which is not desirable and should probably be avoided.
Cameron, what kind of depths of flooding would be likely at the road, given what we do know about the edge of the model?
What depth? So when it comes to the depths of flooding on Sir Francis Drake, that's a great question. The model as it is constructed, I don't think can really accurately estimate the flooding. What this is kind of representing is there being a wall right here that the water cannot pass. And at the end of the 10-year flow, you have depths of around, a quarter foot, a half a foot at some points. And that's not to say that there will be a half foot on Sir Francis Drake. That's just to say that in real life, water could pass through this boundary and would probably be sheet flowing across Sir Francis Drake. I wouldn't expect huge depths to accumulate on Sir Francis Drake because there is lower lying land right here. But you would likely have a few inches of flooding if I'm, going to give a numerical estimate.
Yeah, great. Thanks for clarifying that.
Yeah. And that concludes our examination of the modeling results for the second round of Fish Hatchery Creek modeling. Thanks.